Okay, now I want to give you some examples solving inequalities using the addition principle. This is, we know the addition principle from solving equations, basically solving for an unknown variable using one sequence of steps or multi-step equations. So we're really continuing on with the same concepts. We're just working with inequalities. Now, what I'm going to try to do here is I'm going to give you some examples, and then we're going to graph our result, our solution, and then we're going to also check, and I'm going to show you how to check, because sometimes people forget that checking aspect. And when you check your answer, that's a way for you to make sure you are doing the math correct. All right. Let's go ahead. The first example is going to be x plus 3 is greater than 7. Okay, this means greater than. All right, notice there's no equal sign underneath, so it's just greater than. So addition principle states that we're going to add the opposite of the sign, and this is a positive 3, so we're going to add a negative 3. And I like to write it just as minus 3. And then we're going to do the same thing on the other side. So we've got x is greater than 4, because this positive 3 and negative 3 cancel out. That becomes 0. X plus 0 is the same thing as x. So we've got x is greater than 4. Now if I were to graph that, okay, and I'll just draw some tick marks at, at even intervals. Let's say we've got 0, 1, 2, 3, 4, 5, 6, 7. Notice we don't have x is greater than or equal to 4, so it's going to be an open circle on the 4, and it's going to be any number larger than 4. So I want to make sure I kind of shade in that line going in the positive direction. Okay, numbers that are larger than 4. Okay. Now, let's go ahead and check to make sure that is correct. All right, so let's say I'm going to pick 5. 5 is larger than 4, so if I plug in the 5 instead of the x, I'm going to have 5 plus 3 is greater than 7. Well, 5 plus 3 is 8, and sure enough, 8 is greater than 7. Sorry about that. You can even pick a number really close, like say 4.1. 4.1 plus 3, is that greater than 7? Well, that's going to give you 7.1, or 7 1/10. Yes, it's 1/10 greater than 7, so that would also be true. So these are true. Now if I wanted to double check, maybe try in a smaller number, just to kind of see what I'm going to get, play around with it. This is an opportunity for you. Let's put in 2. 2 plus 3, is that greater than 7? Well, 2 plus 3 is 5. 5 is not true. 5 is not greater than 7. Okay? And so only solutions that are greater than 4 is going to make this original equation right here true. All right, let's do another example. Get some more paper. Let's zoom out a little bit here. Okay, let's try x minus 6 is less than negative 10. X minus 6 is less than negative 10. Again, the addition principle states that we're going to add the opposite. So we could add a positive 6, add 6 to both sides, and this is going to cancel, so we have x is less than, and we've got a negative plus a positive. We're always going to subtract in that situation, and then the answer will take the sign of the larger number. So 10 minus 6 is 4, and because we've got a negative 10, that's going to be a negative 4. So x is less than negative 4. All right, so we've got -1, -2, -3, -4, -5. 1, 2, 3, 4, 5, 6. All right. Notice this is not, it doesn't have an equal to component in the comparison symbol, so it's just going to be an open circle at the 4. And x is less than -4, so we're going to go to the left to infinity. Okay, now let's check, because that is important. So let's say -5. -5 minus 6, is that less than -10? Well, -5 minus 6, you can change a subtraction to an addition by following the additive inverse, and that's basically a minus b is the same thing as a plus the opposite of b. So if I change, I'm going to keep the -5, add, and this was a +6, so it's a -6 is the opposite. Now we're adding 2 negatives, and so that's going to be a -11. And we're saying that -11 is less than -10, and that is a true statement. You might think, well, wait a minute, 11 is bigger than 10, but we're working in negatives here, so the further away from 0, the smaller the number becomes. Okay, so this is true. So any number less than -4 is going to make this solution, or make this inequality correct. All right, let's do another type of problem. All right, here's one. Let's see, we've got 5x minus 1 is less than or equal to 4x plus 3. Okay, draw a line there. Now notice in this case, like problems we've seen in the past, we've had to move things around. Now our goal is to have a positive x, not a negative x, so that might deter you from moving, say, the 5 over to the right side, because then you're going to have a negative. So let's move this negative, or this +4. We're going to eliminate it over here on the right and then move that over here. So let's do that, and then we'll see what we have. So we're going to subtract, because this is a positive 4x. We're going to add the negative. Okay, so 4x, and we're going to do the same over here. And that's going to leave us 5 take away 4, that's 1. 1x is the same thing as x, minus 1, less than or equal to, this cancels, and we're left with 3, a +3. Okay? This happens to be a multi-step inequality, because now we still have to move things around. Here we're subtracting 1, subtracting a positive, so let's add, we're going to add a 1, and now we're going to add a 1 here, and so we're left with x, this cancels, less than or equal to 4. Okay, now let's do a little graphing, and let's see, I'll draw my graph here. Make sure you see it. Okay, so let's say this is 0, 1, 2, 3, 4, 5, 6, -1, -2, -3. Okay, now this one is going to be different in terms of graphing than the other ones, because notice we have an equal to as part of our comparison. It's less than or equal to negative, or not negative, but +4. So we're going to show that with a closed circle. That means we're going to color it in. Okay. Now, x has to be also x is less than 4. So that means we're going in towards the left, towards the negative infinity. So we're going to kind of color that in, make it darker, and the arrowheads as well, showing that we're going to continue going in that direction. Any of these numbers are possible solutions to this inequality. Now I'm going to go ahead and pick a number and plug it back into this original equation. And let me pick a different color because we're getting into kind of cramming it in here. So we'll go over here. So let's say, let's say we've got 4. We'll use 4 because it could be equal to 4. So I've got 5 times 4 minus 1 is less than or equal to 4 times 4 plus 3. Notice I just plugged in those values. Wherever I saw x, I plugged it in. Okay, hopefully this pen will work. Now we're going to use order of operations. 5 times 4 is 20 minus 1. 4 times 4 is 16 plus 3. We get 19 is less than or equal to 19. And so that's true. Okay? So let's say we pick a number less than 4, like 3. Let's pick 3. So we'll go 5 times 3 minus 1 less than or equal to 4 times 3 plus 3. So we got 15 minus 1. And 4 times 3 is 12 plus 3. That's going to give us 14 is less than or equal to 15. And yes, that's true as well. And so you'll continue to get true statements here by plugging in numbers that are less than 4. And if you didn't believe it and you wanted to keep plugging in different numbers, feel free to do that. You know, if you thought, well, maybe it's wrong, maybe 5 would work and that would be a greater than, let's go ahead and try that. Let's say 5 times 5 minus 1, is that less than or equal to 4 times 5 plus 3? So 5 times 5 is 25 minus 1, that's going to give you 24. And we got 20 plus 3, that's 23. Notice that 24 is not less than or equal to 23. So this would be not true. Okay? No. All right. There is, let's see if I have any more examples. Nope, those are all my examples for now. I'm going to give you an assignment in class that will provide you more practice using the addition principle. In the next video, I'm going to talk about multiplying and dividing to solve for n or x. And then there is one exception that I'm going to talk about when you're working with negative numbers, but we'll talk about that in another video. Anyway, as always, if you have questions, ask in class.